Hey everyone, happy Wednesday, hump day. Hey, look who's on here. Josh Rugger Weather. It never sleeps weather. I love it. But hey, I want to give you a quick update because I'm going to tell you this. I don't think the forecast is representative on what we're actually going to see tomorrow. And what I mean by that is there's going to be a lot of altering forecasts and different forecasts. And so I just want to let you know that rain is looking likely tomorrow afternoon and especially tomorrow evening. And you know what happened on Tuesday afternoon into the evening for the evening commute? This is a big heads up that we could see a similar situation. Now, not necessarily as intense storms because we're not going to have the extreme. We're not going to have the instability like we saw on Tuesday. However, with that being said, we're going to dive right into it, and I'm going to give you some reasons why I think rain is looking very likely tomorrow. Now, why is this important that I'm giving you this update? Well, number one, Bite Light is tomorrow evening at the Jones Center. It's the LPGA Northwest Arkansas, the golf championship that's taking place. It's the Walmart Northwest Arkansas Championship presented by P&G. That's the full title, but it's just that ladies golf tournament, and then there's different events around it. So the golf tournament's later on in the month of September, but Bite Light, the second one, is tomorrow afternoon. So what are the rain chances? They're actually looking pretty good. So we're going to go in here, Facebook Live hype. Yeah, well, we're going to hype up the rain chances because I think it's going to happen. How about this one, Josh? This forecast is harder to tackle than Darren McFadden in an open field, especially for South Carolina. Remember that when D-Mac ran all over South Carolina for it was like 300 yards or something like that. It was crazy. I was at that game. It was pretty awesome. I was on the sideline of that game too. That was amazing. All right, here's what we've got. Satellite and radar showing this boundary that remember what came through yesterday? Well, that boundary is stalled out. Now, I personally believe by tomorrow we're going to see a little bit of a severe weather risk expand. Maybe not right at 6Z when they issue the first outlook, but I think later on in the afternoon we're going to see that with showers and storms. Notice, though, that we've got the potential for heavy bursts of rain. So thunderstorms, I think this is going to be a marginal risk as we move into tomorrow afternoon. And here's what it looks like with the excessive rainfall forecast. Now, at the moment, it doesn't show as much over northwest Arkansas, but the latest models continue to increase this and move this northeast. And so I think more storms are looking likely, and I think this is going to be shifting northeast a little more. Yes, the heaviest rain will be northeast Texas, but don't discount us by any means. All right, so let's break down why all this is occurring. First of all, we're going to show you that you can see it too. There's a system in these northern plains that is dropping southeast. And so if we zoom in on this, you can see it right there. Very evident. Now, while this system doesn't directly impact us, it is going to bring that potential for some showers and storms as pieces of energy. It kind of picks up energy and moves it east. So there's the system that's moving in. It's, as you can see, it's just northeast of Denver. So this originally wasn't expected. The front was going to push through, and then everything was going to kind of remain pretty chill. But in terms of rain and storm chances, however, that has changed because, as you can see, the system's diving southeast. So why is that important? Well, because just like with a hurricane, when a hurricane starts approaching the Gulf or the coast, and let's say there's a big trough of low pressure, even before it encounters that trough, it starts shifting directions and it gets deflected, which is exactly what this tropical system in the central Atlantic is going to do. As it's moving northwest, it's going to get deflected to the east. But here is this giant low that's to the west. Now watch, as you can see, yes, it is retrograding and it is moving away. So long range models, lower resolution models show this energy retrograding or going to the west. But the problem is that that's not the energy that's going to bring us the rain and storms. The energy that's going to bring us the rain and storms, as you can see, is in fact right here, just to the northeast of San Angelo. You can actually see too, right at the end, there's a little bit of an upper level spin. So this will probably develop into what's known as an MCV. An MCV can provide additional thunderstorms And I wouldn't be surprised if we see rain earlier than expected tomorrow, looking at this high resolution water vapor. And there's the energy moving in. Dark spot right there showing that energy. So, what we're going to do is we're going to zoom back out. We're going to look at the wide view. The newest HRRR is coming in and it shows storms. So, here's what we've got. I know you want to know about time, but before I show you the future radar, I've got to show you why I think it's going to rain and why a lot of the other models are showing rain as well. But you look at your Apple weather, and I don't know. You let me know. Look at your Apple weather on your app and see if it shows any type of rain tomorrow. So here's this system. Notice it diving southeast, and at the same time, I'm going to back that up. So you got this system that's by Wichita, and you can see that diving southeast. Now, the energy from that system doesn't make it that far south. It's going to kick east. However, look at this low that's getting absorbed to the west of Dallas, and then watch it start kicking eastward as there it is, starting to move in. And so let's kind of look at some of those rain chances here. So here we've got 3 o'clock in the afternoon showing some isolated storm activity. 6 o'clock, we've already got storms. And then you can see additional storms, 7, 8 o'clock. And it kind of reminds me a little bit about Tuesday when you had heavy rain potential. And then watch what happens overnight, Thursday, not Tuesday, Thursday, overnight Thursday into Friday. And then look at this. See the low? You can see it. There's a disturbance. And that disturbance right there is going to provide a little extra lift, a little extra support, a little extra oomph, if you will, and that's going to lead to more storm activity. Then as you see it kind of spin, it sits and spins over our area, and that continues to bring rain chances pretty much on and off throughout the morning on Friday. So, yeah, exactly. This is exactly why your Android, this is why I wanted to do the Facebook Live, because I highly doubt that it's going to be just very isolated activity. It doesn't make sense. And so you're going to see there's the spin, that's the support. Now, this is the 18Z future track model, and you can see that it shows quite a bit of rain by 3 o'clock in the afternoon. So 2.16 in Fayetteville, you got 1.59. So that's quite a bit of rain. And if we look at a zoomed in view here on the precipitation, let's see, I think I got it. Rain extended. Yeah, here you go. So let's zoom in a little bit more and let's see what we got. And so, by the way, there's rain already and storms popping up during the evening, as you can see. And I saw someone reporting what's Cassville going to do. Well, it is going to be kind of hit and miss in terms of who gets the heaviest rain. But as you see right there, there is a bullseye of some heavy rain by Fayetteville. Springdale, about 3/4 of an inch. Huntsville, though, 1.61. Now, that's just a computer model. That's just a computer model. So it shows you that not exactly how much rain you're going to get. But what it does show is there's rain tomorrow. Here's the thing. It's not just one model. Now, while that might be the most aggressive model, let's look at a different one here. So this is the graph. And you're going to see the same exact thing. Here comes this energy from the west. And there's the shower and storm activity popping up during the afternoon into the evening. Now, this focuses a little more in the river valley, which is a possibility, but I don't tend to think so. Looking at the energy moving in. Typically, the models underdo the dynamics. And then I think the rain is going to taper off Friday morning. And then I think we see more daytime heating. I lowered the temperatures, by the way, down into the lower and middle 80s at best, because as you see, we still got that rain and storm activity. And then you can see our next system moving in. Now, what about the Razorback game? Well, this takes us to about Saturday afternoon, and we are looking at mid 80s. And I don't think the rain chances are as high for the Razorback game. So that's good news. But there's still some isolated showers and storms that could pop up. Now, here's what I want to do after this. We're going to go and we're going to add the computer model. This is the very latest HRRR that's uploading right now. And it's the 0Z. I'm going to refresh this real quick just to get all the latest data. And here it comes. Here comes that little Vortmax. See the spin? Look, this already has rain coming in about 3 o'clock in the afternoon. Judging by the water vapor that I saw, I would tend to agree that that looks pretty legit, that that's going to happen. And so if we continue to move along in time with this, watch what happens. More storms. This doesn't look like a 20% chance of rain to me, according to different various apps. And then look, you can actually see the low churning right over us. So there's that spin. There's the vorticity. And if we look at upper heights, you can actually see this spin. So here's what we're going to do. We got to zoom out just a little bit more. And you can actually see this spin getting absorbed by the upper level low that gets kicked in from the northwest. So here's all this vorticity. That low, yes, I know that the center of it is retrograding, but this is not retrograding. And why? Because it gets absorbed by this system right here. So this is going to be our low that's west of Dallas that lifts northward, and then watch it get kicked eastward, just like a tropical system, as those southwesterly winds aloft start pushing that in. And here it comes. And there it goes, starting to get kicked in because of that giant trough that's to the north. And as you see, the bulk of the energy remains to the north, but there is plenty of energy there for thunderstorms and heavy rain at that. And I don't think this is going to change. So if we look at a different model, here's the ARW, and that shows a ton of vorticity. Look at all that. And then you can see how that once again gets absorbed. Now, by Friday evening, I think the rain chances will be less, but there is another wave coming in. But I think our atmosphere will be overworked and the instability will be less. But this is some of the stuff that meteorologists look at, by the way, just to let you know. We don't just what I say, rip and read, but there's the low coming in. These are all these little spins. Remember, the atmosphere is a fluid. Here's this low that's getting absorbed by the southwesterly flow. That kicks it eastward, and voila, you've got storms. So if we go back to upper air winds, we can look at the 700 millibar winds. There's the low. And by the way, that's a lot of support. That is not just some weak system that doesn't bring some enhanced storms and severe weather. I think that we do see the potential for some thunderstorms that will be severe. So, all right, I've been focused on that. And so what I'm going to do is I'll kind of remove all this and we'll go back to some comments. So just one more reason that Android is the way to go. Well, Android said 15%. But what does the Apple weather say? And HRRR sometimes has a few too many. HRRRing, it does go a little bit crazy. Dan, you have the power to lower temperatures. Why aren't you doing this? Yeah, no kidding, huh? If I had the power, I would have done that a lot sooner. Any chance there will be time tomorrow evening to mow? You're going to have to be ducking and dodging storms. I personally believe that if you are going to mow, I would do it during the late morning. I don't think we're going to have as much dew points tomorrow. So, yes, microburst potential will be possible. In fact, why don't we get back to the I'm going to load something else up here. I'm going to load up the sounding for the HRRR, and we'll look at that real fast. Okay, this model's coming in. I'm going to zoom in a little bit more. Not quite all of Northwest Arkansas. I'll bring this up here in just a second. And then we'll take it upper air dynamics. Severe weather. Let's see. We're going to look at a sounding here. So let's look at, Thursday afternoon. I think that's good. And we'll look at the 1 kilometer above ground reflectivity. We'll click on this. Here comes the sounding. Oh, yeah. Definite microburst potential. Now, convective temp is 90. So let me bring this up. Let me show you what we're looking at. Again, we're really geeking out here. But microburst potential is definitely there. So this is the HRRR sounding where it's got, look at that, the LFC and the LCL right at the same level. So what does that mean? The level of free convection is the LFC, and that's right in this area. The LCL is down here. It's almost exactly the same. So the cloud base is going to essentially be the updraft and thunderstorms. very weak flow in the low levels. So the tornado potential is almost non-existent. Um, and then you've got a little bit stronger flow aloft. So what does that do? That's going to blow those anvils downstream. Notice no supercells. I know, blah, blah, blah. Which I agree. It'll be kind of more multi-cell, but that is definitely microburst potential. Look at the downdraft cape, close to 1100. And then you can see that still has instability. Look at the temperatures getting up before this stuff collapses. We've got 88 for the high. I went 85. I think there's going to be a little bit more cloud cover and rain than expected. So that's why I went a little cooler. But again, we're kind of looking at all this stuff and I mean, really geeking out in terms of the computer modeling. But you'll see here that we do have that. We do have that enhanced V or V sounding. So this is going to be more wet burst, wet microburst potential, because as you can see, it's pretty saturated all the way up. So that is definitely microburst potential, which is why I think personally, as we get into tomorrow, there's going to be a severe weather risk. So this is all different. Hey, I absolutely can, Lisa. What causes a microburst? Well, I've got a good graphic for that, and I'll show you. Now, I will have to close this out here pretty soon because I got to get ready for Fox. Okay, so here is a microburst. This is what a microburst does. I'm going to load this up, and let me go to the weather graphics. Okay, so Lisa, and for others, this is what happens. So a thunderstorm develops. And I'm gonna kind of step through this. I'm not gonna go all the way through. So there's some dry air. Now this is a dry microburst, by the way, not a wet microburst. But there's not as much dry air with a wet microburst. You've got this thunderstorm. Remember that LFC and LCL. That is essentially the top of the atmosphere. So let me go. Here's what I'm gonna have to do. I'm gonna have to load up this graphic so I can kind of point stuff out to you. I'm going to throw this in to the weather graphics. There we go. Pause this. Okay. So now I can kind of I can point some stuff out here. So this right here is the cloud base, or known as the LCL. Well, the thunderstorm is going to develop known as the LFC. That's where the air is going to continue to rise all the way to the top of the troposphere. But notice how high this is. Because it's so high, that allows the rain as it falls a longer time to evaporate. Remember, evaporation causes cooling, and the cooling essentially causes the air to fall and accelerate. So this is what was happening west of the air, Arkansas Children's Northwest. Now remember, when this air hits the ground, it hits and it spreads out, and when it does that, it forces the air outwards. So you can see the way that that happens. So winds up to 100 miles an hour, not out of the question with that. And that's how a microburst happens. So essentially what happens is the thunderstorm collapses. And when the thunderstorm collapses, what happens is the air starts sinking. As it's sinking, it's cooling because it's evaporating. As it's cooling, it's becoming heavier. So that's why it accelerates. It's getting heavier, 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 and then boom, it hits and spreads out. And so that's what a microburst is. That's why it happens. And that's why all those power lines were down in a northerly direction, because the microburst hit south of 412, just west of Arkansas Children's Northwest, and just north of Arvis Ballpark. I was watching it along with Josh. So those bases are going to be way up there. That's right. And when they're up there, and it's when you go up there, you don't want me to go there. But the enhanced V sounding. So, anyways, that's what a microburst is. Now, there was one other thing I was going to do. I wonder if I think I actually have a really awesome example of this because it happened in the River Valley. Well, it's happened a lot. This has been the year of the microburst, to be honest with you. And so let me check this out here. If I go to export, let's see if I can find one, and let me see if I can play it. Aha, perfect. I actually have a couple of microbursts. Open with VLC Media, stand by. Yeah, I think this is a really good one. All right, back to our StreamYard, and I'm going to stop this share. I'm going to try to share something else. I don't know if it's going to work. Yeah, it does. Awesome. All right, so this is a time lapse from Mount Sequoia. And remember the graphic on the left. You see exactly what's happening. So we've got the cold air that's rushing out, accelerating, hitting the ground. So what does this look like in person? This is what it looks like in person, as you'll see. So the microburst is happening essentially right here. The air is collapsing. And as you'll see, here it comes, rushing down to the ground. Notice how when it hits, it spreads out and spreads out in all directions. So once again, we'll show that again. This is a thunderstorm collapsing because remember, the updraft is rising. It can only rise so long, and then it collapses. It spreads out. You can actually see the rush of wind too. Look on the left side or the south side of the microburst. Those curls right there represent essentially eddies, and along that you get the rain foot, which shows very strong winds. So that's one example. Close that out, and I'll show you one more because that was a dry microburst. That there wasn't as much precipitation, and then I'll show you a wet microburst. So let me go to that real quick. And well, what happened there? Oh, here we go. Okay, now this is a wet microburst, and you're going to see a lot more precipitation. So I got to share this. Stand by. Go to share. And so this is the time lapse from the Fort Smith Public Library. So here's the storm. Notice how there's no rain. The top of the cloud base, basically the bottom of the cloud base is known as the LCL. And if the LCL and LFC are pretty close together, you got a thunderstorm collapsing. Here's the microburst just to the right or north of Rogers. And then look at that at the very end. You just see it just gush. Notice how it accelerates too as it's coming down. So one more time. There it is. There's the microburst. It's spreading out. So what does that mean? It means we can get some pretty strong winds tomorrow. That basically sums it up. All right, ring around the moon tonight means rain. I look a little tired. Well, I'm always looking tired. All right, so here's the long range forecast because you already saw what happens on Thursday and Friday. So let's get back to this real fast, and then I'll shut it down in about a couple minutes. So here's and remember, this is just some model data at this point. Saturday afternoon, maybe some isolated storm activity. Not as much. Watch this Saturday evening, though. A little bit more development. So maybe the game will be okay, but then the second half of the game or maybe towards the end, there might be some rain. I don't think there's going to be any for tailgating, though. But it is early in the forecast period. We're Wednesday, and that's Saturday. Sunday, I think we get more rain and storms, so we will see more storm chances. Monday, we'll see storms. Tuesday, we'll see storms. Wednesday, we'll see rain and storms. So, and the models are all over the place. So check this out. The graph shows 1/100th of an inch. Now, keep in mind, this model showed 1/100th of an inch in Northwest Arkansas when we had the microbursts and all the damage and all the flooding and unfortunately the fatality. It didn't have any rain, barely. Graph shows 3.05. The European, it's not as much, but it does show rain. But remember, it doesn't get all those fine scale localized details. It's a little bit lesser resolution. It's a 9-kilometer model. Then you got the GFS, which shows, hey, a lot of rain for the next 3 days. And then the NAM, which is basically never accurate model. You see about 1/100th of an inch and 10th of an inch. It's way underdone. I don't know why the NAM is even in existence anymore. It's basically trash. So that's that. And then last thing I'm going to show you is the timing of all this. And this is probably what you wanted me to start with. But here's a look at the rain timing for tomorrow. So in the morning, you're okay. Late morning, yeah, you got some storms. Tomorrow evening, pretty good chance of storms. And then Friday morning, it's going to kind of taper off, but still remain. The only reason I didn't go higher than 60% is because, as you saw, there's uncertainty between the amounts. So the coverage is questionable, and also the duration is questionable. But that's it. Get ready for rain tomorrow. That continues into Friday. An active weather forecast will remain. And yeah, basically just get ready for that. One more thing here. 5% sure. Okay, anomalies. Nope, I don't want that. I want that. Yeah. High res. And I'm going to go to 12Z. There's one more thing I want to show you here, and I think I can get it. Yes, I can. Perfect. Okay, so why do we have the rain chances coming in? You could turn on the lights, by the way. Why do we have the rain chances coming back after the system moves out? Like, where did those come from next week? It was supposed to be clear and sunny the whole time. Well, not anymore, because we have a system diving in from the north. This is really kind of a wild weather pattern, but you're going to see this as I load this up with the forecast loop. And so here's this vorticity that comes in from the south. There it is, getting absorbed. Now that's pretty strong. That's even stronger than what we have here. So it's the small stuff that makes the big stuff happen tomorrow, and there's a system coming in. So that brings us the rain. Then on the back side of the system, we have a little bit of pieces of energy. This, by the way, is Friday night, so probably some subsidence on the backside. Now check out this giant low that's to the north. Watch what happens with this. Because of the blocking pattern, you've got essentially an omega block, a pseudo omega block. It doesn't go anywhere. And so on the backside of this system, diving in from Canada, here comes this low. And look at that blocking pattern riding the eastern side of the ridge straight south. And then there is your rain chances for Sunday, Monday, and then watch how this thing just cuts off and churns right over us. And then another piece of energy dives in. So that's just too much energy around to completely call off rain chances. Pretty wild. We'll play that and we'll loop that so you guys can see it. If I speed it up, you'll really see the way that the atmosphere does behave like a fluid. And it's all these little spins that will make the difference in the forecast. All right, guys, that does it. I've got to run. Hope you had fun geeking out with me on Facebook Live. And so get ready. Rain's coming tomorrow. We'll see if those 20% forecasts on the apps are correct. I don't think they are. I'll be on Fox 24 News at 9 with your 7-day forecast. See you guys later.